All right, so in this lesson, we're going to mainly talk about the fact that dilations and the relationship between dilations and angles. Now, dilations change the length of the sides, but the dilations don't change the measure of the angle, so it preserves the angle measure, okay? So let's take a look at exercise 1. So in the following diagram, angle BAC has been dilated with a center of D and a scale factor of 2. Okay, so we're going to list all parallel rays shown in the diagram. So AC is parallel to A prime C prime, and AB is parallel to A prime B prime. All right, so using our protractor, what are the measures of angle 1 and angle 3? So you guys don't have protractors, but I do. So this one is about 35, so angle 1 is 35 degrees, and angle 3 is, again, 35 degrees. Okay. So as you can see, angle measure is preserved in dilations. All right, so this right here just kind of talks about that. Dilations are angle preserving. In other words, the angles of a geometric object do not change when it's being dilated. All right, so let's take a look at exercise 2. So if triangle DEF, so DEF is dilated by a scale factor of 5, then which of the following statements would be true? Okay, so we have DEF and then D prime, E prime, and F prime. So as we just talked about, the properties of dilations do not change the angle measure. So 1 and 3 does not make sense because you want the statement that would be true. All right, now our scale factor was 5. Now this one is DE is a fifth of the length of D prime E prime. Okay, so maybe, right? So let's just say this is 1. This would be 5. So the length of DE is a fifth of the length of D prime E prime. So that's true, but let's check out 4 just in case. So EF is 5 times the length of E prime and F prime. Well, EF would also be 1/5 of the length of E prime F prime. So that's not true. So our answer is choice 2. All right. All right, so let's look at the next page. All right, so using tracing paper, we want to verify that the angles of triangle EFG are congruent to the angles of E prime, F prime, G prime. Now, I'm not going to do that, but we know that a dilation preserves angle measure, okay? So this is the this is the image and this is the pre-image. Just like completely skipped over that. All right, so again, angles are the same. B, we want to graphically determine the location of the center of dilation and mark this point B. Okay, so to find the center of dilation, we're going to draw a line through F prime and F, so the image and the pre-image. We're going to do the same thing here, draw a line through the image and the pre-image. Same thing here, draw a line through the image and pre-image. Okay, so we're going to mark this point D. All right, so using our ruler to measure lengths, calculate the scale factor to the nearest tenth. So our scale factor is new over old. All right, so verify with at least 2 sets of sides. Okay, so let's do the length of F prime G prime over the length of F G. So this is, let's use centimeters. So F prime G prime is 5.5 and FG is, I don't know, like 3.7. All right, so 5.5 divided by 3.7 is 1.48686, which is approximately, to the nearest tenth, 1.5. All right, so let's take a look at exercise 4. So in the diagram of triangle ABC below, D and E have been located on AB and AC such that DE is parallel to BC. Now we want to give a dilation that will map BC onto DE. Okay, so this is our old and this is our new. So we want to specify both the center and the scale factor of the dilation. Well, we know our center would be A. Now we need to state a scale factor. Now you guys are going to want to measure these sides and find like a numerical scale factor. However, as you're going to see moving forward, a lot of our scale factors are going to be left as ratios. Okay? So there's different ways that we can find our scale factor, or different ratios that we could use to do scale factor, or to state our scale factor. Okay, so remember, scale factor is new over old. Now, our old is this whole triangle, so AB, BC, and AC. And our new is AD, DE, and AE. So we can choose one of three ratios for our scale factor. Now I'm just going to write all three so you guys can see it, but you guys can just pick one. So our new, so we could do either DE over BC, we could do AD over AB, or we could do AE over AC. Okay, so you can, I'm just gonna pick this one, but you could choose this, either of these two, and that's fine. All right. All right, so let's look at B. So if ABC was transformed using the dilation specified in A, explain why its image triangle A prime, B prime, C prime would be congruent to triangle AD. Okay. Now point A, as we know, is going to map to point A because that's the center, so it's not going to move. Now point B would map to D, and point C would map to E. Okay. Now since all three vertices are going to be mapped of triangle ABC are mapped to the three vertices of triangle ADE, these two triangles would be congruent after the dilation. Okay. All right, so let's look at the last one, letter C. So if AD is 10, AB is 15, BC is 12, and AE is 14, then we want to algebraically determine the lengths of DE and AC. Now, this is going to start on the concepts of similar triangles, and to really show you and explain to you what we do here, I'm gonna draw these out on the back so I can really explain to you and so you guys can really see it. So I'm going to separate these triangles. So this is A, B, C and this is ADE. Okay. So AD is 10, AB is 15, BC is 12, and AE is 14. So we want to find DE and AC. So I'm going to call DE X, and I'm going to call AC Y. Okay. Now here's the thing. When we want to algebraically solve for missing sides of a triangle that aren't right triangles, when we have similar triangles. Now, we're going to get into the concept of similar triangles in the next lesson, but I want to start talking about this so you guys can start seeing it and start understanding it. We want to set up proportions. Now, proportions is like a fraction equal to a fraction, okay? So to solve for x, to solve for y, we're going to set up two different proportions, all right? Now, the key to this is to understand corresponding sides. So 10 and 15. So DA and BA are corresponding sides. This side and this side are corresponding sides. And these two sides are corresponding sides. Okay? So let's set up a proportion to solve for x. Okay? So I have all right, so we want to solve for x. So let's start with x. So x over, now 12 corresponds to x. These are corresponding sides. So I'm going to do x over 12. So corresponding side over corresponding side. Now I need two numbers here to help solve for x. Now I'm given the lengths of these two sides. I know this length and I know this length, so I'm going to use them. Now I'm going to put 10 on top because it's part of the same triangle that x is a part of. And I'm going to put 15 on the bottom because, again, it's the same part. It's the triangle. 15 is a part of the same triangle that 12 is a part of. Okay. So I have x over 12 is equal to 10 over 15. Now to solve for x, first thing I'm going to do is I'm going to cross multiply. Because there's an equal sign, I can cross multiply. So I'm going to do 15 times x is equal to 10 times 12. Okay. So I have 15x is equal to 120. Now I divide 15 both sides, so x is equal to 8. Okay. So the length of DE is equal to 8. All right, so let's look at solving for y. So again, I have to set up some type of proportion. So I can do y over, now 14, this side corresponds with this side. So I'm going to do y over 14. Now I need to go back to this triangle, the triangle that y is a part of. Now I'm going to use these two sides again. Now since 15 is a part of the same triangle y is, 15 is going to go on top, and then I'm going to put it 10 on the bottom. So now I'm going to do the same process. I'm going to do cross multiply. So 10 times y is equal to 15 times 14. So I have 10 times y is equal to 210. Now divide by 10. So y is equal to 21. So the length of AC is equal to 21.